Alright, we got Unit 10, we got our introduction into circles. Today we will be talking about arc length, we'll be talking about arc measures, and then also radians. So let's talk about this here. You got arc, 2 points on a circle and all the included points between. So it's kind of like saying like this outside part of a circle. You have minor and major arcs. Minor arcs, that's less than 180 degrees around the circle, and then major arc is more than 180 degrees around the circle. And we're going to assume we have 360 degrees around a full circle. Alright, we also kind of talk about sectors and the arc lengths today as well. Sector, probably not as much, but sector, it's kind of like I guess it's the piece, what does it say here, from the center to the edge. It's kind of like a piece of pizza, so it's like saying like all of this stuff right here, so the angle ACB all the way out to the arc AB and everything in between. So it's like a piece of a circle essentially. Now the arc length of something, that's like the outside, it's that true distance around a circle. So you could go and like measure that and say, okay, it's like 20 centimeters from A to B going along that curve right there, and we'll talk about how to solve for those in just a moment. So let me get my notes. Alright, so anyways, find the measure of each arc in circle C. So the way I like to do these here is just find all the inside angles, and then all the arcs on the outside correspond to the central angles that you have here. So I got like a right angle there, so obviously that's got to be 90 degrees. Over here on the other side you got 90 degrees as well. Right here you should have a linear pair, so that this should be, I guess, 50 degrees. And then all of these arcs that are across from it, as far as how many degrees they are, should correspond with the central angles. Now this is a little bit different in arc length, because I'm not actually talking about the lengths of these, I'm talking about the measures of, how far around you're going right there. And then from here we can go and fill in the rest. So like, for example, AE, the arc AE is 90 degrees. Actually, I think there should be a little M out there in front of all these. Okay, next one, what do we got? ED, I guess. ED, we went and found that was 50 degrees. Okay, DBA, so that is starting from D, going towards B, and then finishing at A right there. So that should be 220 degrees. So that's a major arc. AED, now this actually isn't written in the correct format. AED right there, most of you guys would have put 140 degrees, but technically minor arcs, that's a minor arc. So typically those are written like this right here. It should have been just a measure of A and then to D, like that. So that's a typo on our end there. Typically you use the third letter if you're going like the longer way. So like if I wanted the major arc version of this, I would have said something like ABD, which actually I think is the next one here. Yeah, ABD. So that's 220. Notice that that's actually the same major arc as DBA. You should notice you're going in a different direction. Okay, you got the minor arc BD, and that'd be 130 degrees. And then there you go. Okay, name the picture from above. So minor arcs, remember you need 2 letters, and the major arcs typically you need 3. So minor arcs, I'm not going to do every single one here, but you can say like AB is a minor arc. You can say AD is a minor arc. Let's get one more. Let's go DB. It's a minor arc as well. Major arc, something with 3 letters, so you could go ABD, kind of like what we talked about earlier. You could go EAD. You could go BED. Those are all major arcs. Now as far as semicircles go, semicircle is just halfway around, so there's kind of 2 different ways you can do the semicircle there. And to figure out which one we're talking about, instead of just saying ED, so if I say ED, I don't know which direction you're telling me to go, so I'm going to say a third letter as well. So EAD tells me the top portion, or you can go EDB. and actually it should have been EAB, I'm sorry. So EAB and then EDB. Those would be semicircles. One's the top and one's the bottom. So, anyways, next couple here, we're going to talk about how to find the arc length. We need to review real quick on circumference. So, circumference of a circle is 2 pi r. So we can do that here on some of these. 2 pi r on this one would be 2 times the radius, 14, and then pi left in your answer. Or you could get the decimal. This one here, they gave us the diameter, so that'd be 20 pi. And a modified version of this right here is you can say pi times diameter, or you can find your radius. Radius it's got to be 10. So, anyways, you get 20 pi and then feet here for your circumference. So that's pretty straightforward. So arc length describes a fraction of the circumference of a circle. Okay, so the way we're going to find the arc length is we're going to set up a proportion. Okay, so you can memorize all this stuff here. I don't really memorize it that way. I just kind of think in terms of a proportion when I'm trying to find the arc length. With number 9 right here, find the arc length of AB. That means find this outside distance right here to the circle right there. So it's just a piece of the circumference. So we're going to set up the proportion that we got up there, right there. So it'll be just x, and then over 2 pi r. In this case, r is 6. And then that's going to be over your angle, which is 120 degrees, or your angle or the measure of the arc, or how many degrees basically. So 120 degrees out of the full 360. Okay, and then once you're done with that there, we can go ahead and simplify on the left-hand side. I'll tell my kids, 2 times 6 there, 12 pi. You can simplify that if you want there. Some people will start to cross multiply and divide right away. The right-hand side does reduce. If you want to reduce it down to 1 over 3, you can. Or you can keep it 120 over 360. And regardless, we're going to have to still cross multiply and divide. Let's go ahead and, just for fun here, let's change that to 1 over 3 since I do know that it does reduce right there. And then, you would cross multiply. It'd be 3x, and then 1 times 12 pi would be 12 pi. Now, if you kept it like this right here, I would just not type into the pi into the calculator until the very end, and just so you can keep your answer in terms of pi. Final step would be division right there. Divide both sides by 3, and you'd get 4 pi, and then I guess in centimeters. This is exact as far as your answers, or sometimes they'll say in terms of pi. If you wanted the approximate answer or the rounded answer, you would just do the 4 pi, or the 4, times the pi, so 3.14. It's about 12.56. And that'll be it there on that. So this would be the approximate answer. So just be on the lookout for the different styles of answers they want. And that'll be it. All right, so B, pretty much the same thing right here. The diameter is 24, which means the radius must be 12. But when you go back and plug everything into the formula here, when you're doing 2 pi and then r, 2 times 12 right there is going to get you back to 24. So you can say, okay, that's 24 pi. The angle is 60 degrees, or the arc right there, 60 degrees, and then over 360. And this one I'm just going to go ahead and multiply right away. I'm going to call that 360, x, and then equals 60 times 24, and that's going to be 1440, and then pi. And then we'll divide that by 360. And that'll happens to come out to the same thing, 4 pi centimeters. That was a coincidence. That was just because we had a different angle right there, and so happened to come out to 4 pi. Okay, next one's kind of a special one. If you want to put a star next to that, we're not finding the arc length of the short arc here. It's saying find the arc length here of x, z, y. And if we follow it right here, x, z, y is a major arc. It's a major arc since it's 3 letters, and then also we're going in the direction from X. You're going to X and Y, but you're going in the direction where Z is, which is over there. So with this one here, we're going to have to do something to find the angle or the number of degrees right here. So to do that, a full rotation or a full circle would be 360. So we'll go 360 minus the 70 degrees. And that'll get us 290 degrees. And that's what we're actually going to use here for the arc length piece right here, for the formula, I guess. We'll go x and then over 2 pi and then times 10. Some people will just multiply that in their head right away, and that's fine. So that's what, x over 20 pi, and then equals 290 over 360. I guess you could reduce a little bit, but it ain't gonna change a ton. You know, it's still gonna need to multiply with our calculator. So I'm gonna go 20 times 290 here off screen. I got 5,800 equals 360. Oh wait, I forgot my pi. Equals 360x, and then divide by 360. About 16.1 repeating. So I'll put a little line. You had pi still with your answer, and that would be the exact answer. This would be in centimeters. And then if I ask for the approximate answer, you know, multiply that by the pi, and then you should be good then. Okay. Next one here, you got a wheel, has a diameter of 18 inches. What is the distance that the wheel has traveled if the wheel is rotated 50 times right there? Basically, with these types of problems here, they're asking you to find the circumference, and then you're going to multiply by the number of revolutions. So we need to go find the circumference. The circumference formula, you can do 2 pi r, or you could even just do diameter times pi. So regardless of which way you're thinking about it, you're going to get 18 pi right there. And then we're going to multiply that by the number of revolutions. So that was rotated 50 times there. Sorry, getting up and grabbing myself a fancy calculator here. So we'll just do 18 pi times 50. And I'm going to write my answer in terms of pi first right here. So 18 times 50 is 900. And then pi. A lot of times the word problems like this here, you're not going to say, oh, the wheel traveled 900 pi. Most of the times we're actually going to go and do the approximate answer. So I'll take that answer and multiply it by pi right there. The pi button in the calculator will get us about 2,827.4 inches right there. So depending on if they ask exact or approximate, you do use one of those. Okay, last portion of our lesson here is kind of talking about radians, I guess. So radians, let me kind of draw a picture, I guess. You don't really get into these a ton in geometry. You get a lot more into radians once you get into pre-cal. But as far as a radian goes, what it is let's say you take some distance for your radius, r. What you're going to do is you're going to make an arc length of that same distance r around the circle. And you can do that multiple times. And you can get a bunch of these r's, r, 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 and then you're going to have this little bit of a leftover piece. It's not going to completely cut off perfectly right there. Now, depending on what the radius is, it doesn't change how many radians inside of a circle. If you went and scaled this thing and made it bigger, it would be the same exact thing. So you can make it as small or as large as you want. It does not matter. You're going to still have about 6 of those full radians and then some. So as far as the number of radians in a full circle, it's actually approximately 6.28 radians in a full circle. Okay, and actually that number where it comes from comes from 2 pi. So you know how your circumference formula, you have 2 pi and then times your radius? Well, in this case here, that's where the 2 pi comes from in that formula right there. So 2 pi, or approximately 6.28 radians in a full circle. And that is kind of, in my own way, what a radian is. So we can say the number of, I think it's like radii with like 2 i's there for plural, or maybe it's 1, I don't remember. But anyways, radii, multiple radiuses. Yeah, I think it's that. So anyways, the number of radii in a, I guess a round, let's use that word. Around a circle. Now, it doesn't have to go all the way around a circle. We could say like, oh, only 3 radians around a circle, or 4 radians around a circle, or half a radian around a circle, however you want there. Intercepted arc, I guess you can just say this is the arc. Let's say the arc across a central angle. Not really sure why that's in there. It's kind of out of place there. Well, all right. Anyways, use a circle with a radius of 5, and then an arc length of 10 pi. What is the measure in radians of the central angle? And actually, this probably isn't the best example to start out with here, but apparently the arc length, or I'm sorry, the radius is going to be 5 right there, and then we have an arc length, and I'm not sure how far around, apparently of 10 pi. And then we're going to figure out what is the measure in radians, and here's the symbol we use for radians typically. It's called theta. It's one of the Greek letters. But anyways, and then you're going to find the central angle from that. Now, right here, you want to know this formula right here, the radians. So I'm going to rewrite this. The radians is equal to arc length over the radius. And then you're going to simplify that down. So the arc length apparently was 10 pi, and then the radius is 5. When you simplify that down, that gets you 2 pi radians, which actually is a full circle right there, since we kind of already talked about that 2 pi radians in a full circle right there. So this one happens to, the arc length is the full circumference in this case. Now, not all examples are like that, so this one's not really my favorite example. Really, I like these other examples down here towards the bottom to talk about arc length. So like this one here, notice it's not in pi, in terms of pi, but so we're going to go the radians equals this arc length here, so we're about 11 feet, and then over the radius 8 feet. I'm not sure if that's drawn perfectly to scale, but anyways, if you take your calculator and go 11 and then divide it by 8, it's about 1.375 right there, and then that's radians. The feet essentially cancel each other out, so that's how many of those radiuses around the circle. So 1 and then a little bit extra radians. So that's an example where you don't have pi. Most of them we leave pi in the answer. So like look at this one here. Apparently the radius is about 6 centimeters, or I'm sorry, 12 centimeters. So we're going to say the number of radians is equal to, and then what do we got? The arc length is 6 pi units, or centimeters, I guess. And then we'll divide that by the radius right there. So that actually simplifies down to 1/2 pi, or pi over 2, doesn't matter how you write it. Okay, and if you do that, 0.5 times pi, that's about 1.5 or 1.6 radians around a circle. So you can leave your answer in terms of pi. In fact, in pre-cal, that's what they do quite a bit. Hardly ever write radians with the decimal, but there you go. All right, look at this next one here. I guess we got the radians, and then equals 3, or actually excuse me there, 3 over 2 pi, or 3 pi over 2, and then we're going to divide that by the radius 3. Now, if you didn't have a calculator, you can also do the keep change flip when you're dividing by a fraction. So we're gonna multiply by the same fraction, 1/3. Those 3's are gonna cancel each other out, and then you're gonna get 1 over 2 pi again, which is gonna be about 1.6 radians. It's about 1.6 radians, or pi over 2 radians. So there you go. So it's just how many radiuses around the circle instead of how many degrees around the circle. That's the only thing that's different about it.